This is NASA TV.
Here on NASA television, we've been observing the 15th anniversary of the launch of the first few modules of the International Space Station back in November of 1998. In this coming February, we will mark the 13th anniversary of the arrival of the U.S. laboratory Destiny to the International Space Station on a space shuttle mission during Expedition 1. Now, science research has been going on board the station throughout the assembly process. But now that the assembly is essentially complete, the science activity both inside and outside the space station is taking the primary focus of the activity on orbit. A few months ago, the International Astronautical Federation asked International Space Station Chief Scientist Julie Robinson to share the top 10 research results from the station at the International Astronautical Congress in Beijing. And we're pleased to have her here today to talk about some of those things. Julie, I got to start by asking you to tell me about the criteria that you use. If you go thumbing through all of the science and research that's been done over all these years, what were you looking for to decide what would make a top 10 list?
Well, it's a hard choice, and fortunately the leaders of the International Astronautical Federation said they could say, why limit it to so few, so that I could actually stretch it a little bit if I wanted to, which I definitely want to. But what I focused on was what they asked me to focus on, which were research results. And I looked at a couple of criteria. I looked at research results that had been published in really important scientific journals. That's always a great measure of a result. I also looked at research results that were really bringing benefits back here to Earth, where there were cases where people's lives had been saved. Somebody was around today that would have not been alive or not had a good life if it hadn't been for some of those research results. So I tried to look at both of those things. And I also looked at the acknowledgments of their colleagues. So last summer we had some of the results of the last year selected for awards at the American Astronautical Society, the AAS domestic meeting that we have. And so I used the inputs of some of the scientists that voted on those awards as well to help me pick a top 10. And, you know, a year from now I'd pick a different top 10 probably, sure, because things are changing fast.
Well, is the emphasis on brand new things that have been discovered, or as opposed to finding ways to apply things that we know?
Well, science takes time. So, you know, the first thing that happens, there'll be a publication. Sometimes it's not even recognized that that is a groundbreaking publication until several years later. So I tried to balance between sort of new, exciting things, but also to look at some of the things that have been gradually evolving and developing and making things better and better, growing to be something with great impact.
Were some of them pretty obvious picks for you?
You know, I probably have in my own mind a list of my top 30 or 40, and then I really had to go through those and pick the ones. There's some that I just feel like everybody needs to know about. But then because I restricted myself to research, I didn't talk about some spin-offs and technologies that we've developed on the space station that are also saving lives all around the world. So I specifically ground ruled some of those out, and those are great stories in their own right. That
would be at least one of the reasons why you wouldn't have picked the actual assembly of the station itself as one of the achievements.
Exactly. You know, the space station was built for both advancing engineering and our ability to explore space. It was also built for international cooperation and peaceful use of space around the world for all humanity. And then it was built to be the most amazing research platform we've ever had in low Earth orbit. And so that third area, the research, is my area, but all of those things go together to produce the whole value that the space station provides to the world.
How many different research projects, science experiments, technology demonstrations have run through the system in this time?
We've had roughly to date about 1,500 investigations that have been active on the space station, and that's not counting the multi-user instruments where hundreds of people might take advantage of the data, say Earth remote sensing instruments. So we've had a large number of investigations that have been begun or completed on the space station. And then there's always a lot of groundwork that follows that on-orbit activity, and we see the publications come out anywhere from 3 months to multiple years after the on-orbit part is completed.
And there's been participation literally all over the world.
Yeah, over 69 countries have participated in some aspect of either research or education on the space station. So even though the partnership is a partnership of 15 countries, the impact of ISS is truly global.
Let's look at the list. We'll go down the list starting at number 10, preventing loss of bone mass in space through diet and exercise. And that sounds to me, that's something that was already a point of interest before the International Space Station, right?
You could go clear back to the Gemini missions, and people were worried about bone loss in astronauts because all that floating around means there's no forces on your bones, and people knew that that would probably cause astronauts to lose bone right at the beginning of human spaceflight. What's exciting to me, and this is why I think it was also on the cover of the major bone journal in the country, the Journal of Bone and Mineral Research, what's exciting to me about it is that when you study astronauts, you've got otherwise incredibly healthy, strong, fit people, and they go into space and they have this challenge and they lose bone. And what we found after 15 years of research on the space station, we started studying bone in Expedition 1 on the very first crew member. It's taken us several generations of studies, but we've actually found a recipe where if you have the right exercise regime, which includes high intensity resistive exercise, the right diet, the right number of calories, the right types of calories, and the right vitamin D supplementation. If you put all those things together, we now have astronauts that come home from the space station for the first time not having lost overall bone mass density, and that's a huge advance.
And that, in fact, is something that you developed over the course of those 15 years, because the protocols we were using at the beginning weren't having those kind of results.
Right. Early in the space station, our astronauts were losing 1.5% of their bone per month, which is about the same as a woman with osteoporosis would lose in a year.
Wow.
That's really severe. And that was a big improvement off of how astronauts were doing on Mir. So there's been a huge development of our understanding of bone processes, why astronauts are losing bone, and how the bone remodels and recycles itself. Understanding that process helps us protect astronauts so that when they land on Mars, they're going to be ready to do a spacewalk right away and they're not going to fall and break their hip. But it also has the benefit of giving new insights into understanding those same processes on Earth, where so many people are worried about bone loss.
In the case of the astronauts, it's the lack of force on the bones that causes them to weaken?
It is, but it's not the force you think about. It's the lack of forces at an almost cellular scale, where a single cell of a muscle fiber is attached to the bone matrix. And those little forces from the muscles working and carrying yourself around the world are part of the system of bone that we have that helps our bone recycle. If your bone doesn't recycle all the time, it becomes brittle and it breaks. So you have to break down your bone and rebuild it all the time. The bone is a living organ.
And of course, you need astronauts with strong bones to be able to do work.
Exactly, and we track risks for human exploration, and one of those risks is if you lost too much bone on your way to Mars, you get to Mars and are running around in a multiple 100-pound spacesuit on very rough terrain and trip and fall and break something. It may not be possible to get back to the vehicle, for example. So these are they're real risks to astronauts, but they connect to the real risks to people here on Earth. You know, when my grandmother fell and broke her hip, that was an incredible challenge for all of her health. And so for the same reason we don't want astronauts to break their hips on Mars, we really want to take that knowledge and find ways to feed it back to the really active osteoporosis research community here on Earth.
So, and it's a relationship, it's not just the exercise, it's exercise and the diet.
Right, and it's really interesting because vitamin D is one aspect of that diet that's turned out to be important. And NASA had done a study in the Antarctic in a simulated environment, but it gets very dark in the Antarctic. Right. On the space station, in spacecraft, astronauts don't have the sun every day. And from the results of that Antarctic study, they determined vitamin D was much more important. That was actually fed into the USRDA reestablishment of a new level for vitamin D. And I talk to people all the time. I'm one of them, where my doctor said, okay, we now want you to take more vitamin D than you used to take. And it was that overall study, of which the study with the astronaut simulation study fed into that led to that change in the USRDA.
Well, in fact, the next result that you recognized on your list is something that's related to the first one. So, number 9, understanding mechanisms of osteoporosis and new drug treatments. I understand that the breakthrough here actually came in a study using mice.
That's right. So, you know, mice are a model system that we use for studying bone. People study bone loss using mice in laboratories all around the country. And there was a great partnership between Amgen and Biosurf Space Technologies, and it started during shuttle assembly flights. And Amgen flew and used the mice that we flew on these assembly flights to test some drugs that they had in the process of clinical trials. So they had developed candidate drug treatments, but they had not yet been approved for FDA use, or they were just starting them in those stage 1 clinical trials. And they really wanted to understand the mechanism of how the drug might be working. The first of these was related to osteoprotegrin, which is, as it sounds like, maybe a protein related to the bone. And so the idea was to better understand how that remodeling process works and whether osteoprotegrin inhibition could be used to slow it down. And that's a whole new line, a whole pathway of a pharmaceutical treatment for bone loss that's a new one. And that's what Amgen tested in one of their mice flights to the space station.
And I understand they were doing that in order to back up some research along that same line that was already underway on the ground.
Right, exactly. So it's not that they went to the space station and just invented the drug there. What they did is they used the fact that spaceflight has such dramatic effects on bone loss to really amp up the effects on mice and to be able to take a lot of measurements that they couldn't get any other way.
And that's led to a drug that's on the market.
That's right. That's right. The drug is called Democidab. It's under a trade name Prolia. And that trade name or that drug is now on the market. It has some warnings. All drugs have side effects.
Sure.
But doctors are finding that for some patients who can't take alendronate, which is the primary drug that most patients take today for osteoporosis, some patients can't tolerate that. They get stomach upset and things, and this provides an alternative for some of those patients.
Is this a good example of the interest that's being shown by private companies into getting involved in research on board the station?
Yeah, when you think about it, this is really a novel kind of a public-private partnership for advancing human health and even our economy here on Earth. To have commercial companies have the opportunity to go to this discovery zone where you can make extraordinary advancements, really study something you can't do anywhere else, take that knowledge back down to Earth and use it to keep a competitive edge, to develop a new solution to a problem, and then to be able to market that. That's part of why the space station was designated a national laboratory back in 2005. And then in 2011, a nonprofit organization called the Center for the Advancement of Science in Space was selected by NASA in a cooperative agreement. That cooperative agreement lets CASIS, which is what we call them for short, go out and work with other pharmaceutical companies that might be interested in trying something in space. But of course, working with NASA is not something pharma's been doing over the years. So it's very new, and it's really exciting to be working with CASIS as they start bringing in some of these customers and they find ways to take advantage of the platform that we have.
Since you brought it up, what does it mean for the International Space Station, or at least the U.S. part of it, to be designated a national laboratory?
Well, you know, there are other national laboratories around the country, Argonne, Brookhaven, Savannah River, Livermore, and usually you have sort of one government agency that needs 90% of the laboratory, but they often will offer other government agencies, the private sector, the opportunity to come in and use those unique facilities, because a national laboratory means it's a facility that the nation needs to advance its research, and it's opened up to all, not just the one agency that's operating the lab. And that's exactly what the space station as a national laboratory means as well. The really great thing about it is so many other government agencies and entities in the private sector can take advantage of it because there are so many different kinds of research that we can do there.
The next thing on your list has to do with something that has been taken advantage of in this way. The next result on the list, a different kind of thing, though, than what we've been talking about. Number 8, hyperspectral imaging for water quality in coastal bays. Now, I'll admit, at first blush, this was counterintuitive to me. I think you could learn more about the water being right there and sampling the water
rather than going up into space.
What is it that you can learn from an instrument on orbit?
Yeah, so the thing about the space station is it's about half the altitude of most remote sensing satellites, and it has extraordinary power and data. And so there are a number of locations that we built in when the space station was designed, over 30 of them, where instruments could be attached to observe the Earth or to observe space. And one of those instruments is called the Hyperspectral Imager for the coastal ocean. It's the first hyperspectral imager ever flown in space that is tuned to looking at the colors in the ocean. the different wavelengths of light that are going to reflect the best and give you the most information. And so it was really designed to help you distinguish, if you're looking down at the ocean, to distinguish between sediment and algae and all of those other things, the bottom signature, all of those things, and really tease apart the signal that you get when you look at the water. And it was built by the Naval Research Laboratory. It was used for a number of years, primarily for the Naval Research Laboratory, but they offered a little bit of access to other scientists. And this year, in January, we converted that to a fully operational part of the space station infrastructure. So we made it part of the National Laboratory so that not just the Navy, but all of our NASA scientists could access it and request imagery. And one of the great uses that came from its early phase was the Navy had worked with the EPA. The EPA would coordinate the data collections from the space station with times when they were going to be in the water in bays around Florida. And those waters are incredibly complicated because, you know, there's subtropical waters. They've got a lot of algae, a lot of plankton. There's a lot of sediment running off the into the bays from the land. There's a lot of fertilizer running off into the bays from the land. And so they were interested in seeing if they could tune a hyperspectral algorithm to actually tell them what the water quality was. And the reason you want to do that is because you can't always be everywhere in the water. Those sampling, when you send out boats full of scientists to sample the water, that's an extraordinary field effort. And so if you can develop the right algorithm, then your hyperspectral instrument can actually look down and you can predict what the water quality is without being there. And now the EPA, that won an award for innovative science at the EPA, and now they're working on developing an app so that they can then have kind of real-time information about the water quality in some of the bays around the Florida coast.
It's also a good example of research being done on the station that doesn't really require the participation of the human crew.
That's right. You know, crew time is really important because having the human there, interacting with the experiments, talking to the investigators on the ground, all of that is very important for parts of the science, but these instrument opportunities are also extraordinary.
Let's move on to the next in our countdown. Number 7 is colloid self-assembly using electrical fields for nanomaterials. There are 2 terms here already that I need definitions for. What are colloids? What are nanomaterials?
Yeah. So colloids are any mixture of a solid and a liquid that stay in suspension together. And that sounds real goofy, but think of paint. You know, paint is all your pigment particles, and they're mixed into a water and oil base, and they stay together, and you can use them. Another great example of a colloid are some shampoos or fabric softener. Are colloids, where you've got the softening particles distributed in the liquid matrix that you can then measure out.
And these could be things that are for any number of different applications,
right,
but it's all still colloids.
Right, and so when you work with colloids on Earth, whenever you have differences in densities, things will settle out and eventually sediment. And so one of the interests that you have is in having paint not settle out before its time, having a consumer product like a cough syrup not settle out before its time. You know, if a medicine settles and the consumer doesn't shake it up, then they might draw the wrong dose out. So keeping colloids in suspension and really understanding those is a really important part of an area of materials or physical science research. And what nanomaterials are is another area of materials science that interfaces with the colloids work. So nanomaterials are those materials that you assemble together where you can actually get the structure you want, but you're paying attention to that structure molecule by molecule. And since we don't have molecule-sized, you know, tools for putting those together, you have to find ways to get those materials to assemble themselves in the way that you want them.
You're finding some way to manipulate them on orbit.
Right, but on Earth or in space, you have to be clever about how you manipulate them. You can use electronic fields, you can use, you know, try to use all the tricks you have to get the molecules to line up the way you want, to lattice in and form a structure the way you want. If you can control your smart materials, you can make amazing things. And so a lot of people now don't know what nanomaterials are, but they've heard of them because they're providing all kinds of innovations in industry. Better filters, better, you know, all kinds of different things you can use if you can get those molecules to be arranged the way that you want them.
In this particular case, you got something of a breakthrough because of the human participation. You had a little serendipity with one of the crew members, right? Right.
So we had a study going on early on ISS that was starting to look at magnetorheological fluids. Those are fluids that get thicker or thinner when you put them in a magnetic field. And those are important fluids for shock absorbers, bridges. They can be put in a building and they can be firmer, and then if there's an earthquake they can relax and let the building flex a little bit and then firm up again when the earthquake's over. They're really amazing materials. Yeah. And we had a scientist, Dr. Eric First, who was doing a study with a very simple system at first. And in those first experiments, Peggy Whitson on orbit was setting up the settings for what the electromagnetic field would be. She was basically setting the current. And he had these different mixtures of particles in liquid. And she accidentally got a setting a little off. And all of a sudden, the field started pulsing so that the particles, instead of just lining up in nice little chains, which is what they had been doing, they started lining up, breaking apart, lining up, breaking apart. And so that was exciting. The investigator on the ground didn't know what it was. It wasn't expected. We wound up doing a lot more runs than were ever expected. Now he's, I think, on to his third separately funded project. You know, that was a decade ago. And now he's working with these incredibly sophisticated colloid mixes where he's designing the particles that are floating this liquid and using special mixes and then seeing if he can apply the fields to make them self-assemble in the way that he wants. And he's had some really important publications that have come from that work in the proceedings of the National Academy of Sciences. And so that was one of the ones that I definitely wanted to call out for this top 10.
That's very interesting. And next on our list is another result that's in the physical sciences. This is number 6, the new process of cool flame combustion. And I believe this one is like a brand new discovery. Start by explaining what is a cool flame.
Yeah, I had to find that out myself because I don't think of flames as ever being cool. No. And in fact, a cool flame is, you know, roughly a 600 degree Celsius flame, so it's still pretty hot. But we have this great combustion facility on the space station. Many people don't realize, they think of fires in space as being bad, and of course an uncontrolled fire in space is very bad. But we have a facility where almost all the time we're burning different materials. And the reason we do that is because, just like I mentioned, there was no sedimentation, well, there's also no convection in orbit. So when you, if you were to burn a candle on the space station, instead of getting a nice little candle-shaped flame, instead you're going to get this glowing blue ball with no warm air rising off the top of it. And what that means from a scientific perspective is you can model combustion in much simpler set of mathematics on the space station because you don't have all this mixing that can feed the flame, disrupt the flame. So if you think about, another way to think about it is, you know, when you teach a Boy Scout to build a fire, you teach them to make sure you've got the right openings for air to flow through the fire, because that's a very complex process. The math behind that is incredibly difficult to model. So what combustion scientists do on the space station is they try to simplify the system by taking all that convection mixing out of the system and then study combustion in its purest form. And that has some great advantages mathematically, but mathematical advantages also turn into the knowledge that can help you innovate and develop more efficient combustion engines.
Well, you're trying to find out why things burn, but also what causes the burning to stop, right?
Right, and you're even trying to understand, you know, exactly how that burning functions as a system and describe that mathematically. So the cold flame discovery was another big surprise that came. And what happened is we have a droplet combustion apparatus, and we were basically taking little bits of things like heptane, you know, liquid fuels, and heating them up and burning up this little droplet and watching it and collecting data on the temperature, the gases that were coming off, how long it took, and we were controlling different flow rates. And what was discovered is there were a set of conditions where after the normal blue ball occurred, then that blue ball kind of suffocates in its own gases.
Flame goes out.
The flame goes out, and then afterwards there was this glow that reignited. But it wasn't the same blue flame that you had seen before, the same hot flame. Instead, it's this cool reddish flame. And it turns out that there is a secondary combustion process that was not predicted by any of the existing combustion theories. So it's this brand new novel process, and the scientists called it cool flames because it's much cooler than the primary flame was in the beginning.
Spontaneous combustion is almost what it sounds
Well,
like.
it actually hadn't quite finished. People thought it had quenched and stopped, but there was a little bit of time, and then there was another chemical process that could come in an additional set of combustion.
additional research then I'm sure is being done based on these findings.
That's right. That's right. So, you know, basically this facility is operating whenever we can in the background, going through different gases, different flow rates, different combustion settings, collecting all this priceless data that's never been known before, and then all of that data feeds into models that will help us both to better design combustion engines in general, but then to also better understand how things burn in orbit. And that helps us provide fire safety for future spacecraft as well.
In fact, there are several different kind of combustion experiments that are going on beyond just the one that led to this.
That's right. We have an experiment called BASS for burning and suppression of solids, where we're burning all the different materials that could catch fire in a spacecraft and seeing what happens when they actually burn in space. And what we're finding is all the standards we had used for spacecraft flammability, we're assuming that things burn the same on Earth as they do in space, and they don't. So there are certain things that are more flammable in space than we thought they would be, and other things that are less flammable. And in the end, I think the work that we're doing on the space station is going to completely rewrite the fire safety manuals for spacecraft.
You're finding out why things burn, but also, I guess, some insights into how to stop fires that you don't want.
Right, and even insights into how to detect fires, because smoke detectors are assuming that smoke looks like something is detectable at certain sizes, and it turns out soot particles are a lot bigger in space than anybody thought.
Julie, this is great, and I want to thank you for helping me make sense of all of that. These are the things that you wouldn't think about before, and those things are just half of our top 10 list. In our next program, we're going to discuss numbers 5 through 1. That means we're going to learn about advances in how genes turn on bacteria, in advances in neurosurgery, in the study of dark matter. We're going to look at how the station is reaching students of all ages all over the world, as well as potential advances in the treatment of cancer. All of those are among the top 10 research results from the International Space Station.
Read Dr. Robinson's blog, A Lab Aloft, online at blogs.nasa.gov. Follow us on Twitter at ISS_research and on Facebook at facebook.com/ISS. See the International Space Station as it orbits above your location. Log on to spotthestation.nasa.gov. And you can follow the mission. Watch Space Station Live weekdays on NASA television and get weekly updates every Friday on Space to Ground on www.nasa.gov.